This is Chemistry Unit 4, Chemical Nomenclature, naming Type 2 ionic compounds. So the first step in naming a Type 2 ionic compound is the same as for Type 1. You name the metal. The difference now is our second step. You will use a Roman numeral to indicate the charge of the metal if the metal is not from group 1, the alkalis, group 2, alkaline earth, or aluminum, zinc, or silver. So you might remember that those are your type 1 metals, which should be highlighted on your periodic table at this point. Now here are the Roman numerals. We're going to use Roman numerals 1 through 10. So if you do not have these memorized, you are free to keep these on your periodic table as a reference. Now what I'd also like to start with is the labeling of your type 2 metals. So your type 1 metals should already be on the table, and you can see I've got mine in black, and then I used a bright green for my type 2. Now, you can see that I have some lines for my type 2s right here, so you have to be careful. The type 2s are your transitions. So if you look at these first 3 rows, I highlighted these right with my rows right here. Be careful not to include silver, zinc, or aluminum. Those are type 1. But you also do need to include those metals underneath, including over here, bismuth and polonium, because they are pretty common for us to use. Now I did also highlight in green this last row of elements, which are rather recent elements, and they're named after a lot of scientists. We don't really use these too much, but they would fall into your type 2 metals, along with the lanthanides and actinides down here. So I did put them in green, but we really aren't going to use those too much. So where you see my rows of transitions, those are the common metals that we'll be using. So these are considered type 2 because they have several charges or several cations. So if you notice, I didn't write any charges inside of any of these elements because they all have several charges that you have to determine. But my anions over here are still -3, -2, and -1. So that has not changed. Okay, and then the third step also does not change. You will name the nonmetal and then change that ending to IDE. So let's practice. So my first example is called iron 3 chloride. So that 3 is a Roman numeral, and that's the charge on iron. So the first thing you have to figure out, though, is the symbol for iron, which is not IR, which is iridium. It's actually Fe, right? Because we learned why some of the names don't match their symbols, right? It's coming from a different language. So iron is Fe, and the charge is +3. And then chloride is over here. It's in my -1 group. It's coming from chlorine. So the first thing you want to write down are those charges. So it's Fe +3 and Cl -1. Now this crisscross method remains the same. So once you've written down your symbols and your charges, you can simply cross them to get the formula. But remember what that cross actually means. Iron can lose 3 electrons. Chlorine can gain only 1 electron. So to make this even so that it's neutral, you will need 3 chlorines to accept those 3 electrons. And that's why this becomes FeCl3. So again, you don't write the 1, and again, you don't write the plus or the minus. Gold, 1 bromide. So again, 1 is that Roman numeral. Gold is actually down here. The symbol is Au, and bromide is coming from bromine, which has a -1 charge. So the symbols are Au +1 and Br -1. So gold can lose an electron, bromine can gain an electron. So this is a 1-to-1 ratio, it's a 1-to-1 exchange. So the formula is AuBr. You don't write the plus or minus, you don't write the ones. Okay, one more. This is vanadium 5 sulfide. That's the Roman numeral for 5. So vanadium is right here. The symbol is actually V, so careful. That is also the symbol for the 5th Roman numeral. And then sulfide is coming from sulfur, and it has a -2 charge. So this is V +5 and S -2. So you can just do the exchange and come up with V2 F5. I'm sorry, V2S5. So what this actually means is that vanadium has 5 electrons to give. Sulfur can accept 2 electrons at a time. So in order to make this neutral, you would need 2 vanadiums, which means 10 electrons can be given away, and you would need 5 sulfurs, where each sulfur can accept 2 electrons. That's a total of 10 electrons that could be accepted. So 10 are given, 10 are accepted. So that's what that exchange really means. But for your purposes, you simply need to make that exchange and give me the correct formula. Determining the Roman numeral. This is the most difficult part of your type 2 naming because it does involve an algebraic equation to solve this correctly every time. So a lot of you are going to look at this and think that there's an easier way to do this, and that easier way only works some of the time. So if you follow the algebra, you will have the correct Roman numeral every time. So let's give this a try. So my first example is Cr2O3. Now you have to provide the proper name with the proper Roman numeral because Cr, which is chromium, is type 2. It's not in group 1, group 2, and it's not aluminum, zinc, or silver. So that means a Roman numeral is needed. So chromium is actually right here, so it's in this type 2 section. Now you notice there is no charge in chromium's box or in its group. There's nothing there for chromium because it has several charges. You have to figure out which one is needed in this formula. So what I've done is I've set this up and I've color coded it. So it's chromium's Roman numeral that we need to determine, so I put chromium in red. And then oxygen will remain that light purplish gray color. So here's the setup. So you basically use what was provided. X is my unknown. It's chromium's charge that I don't know. So chromium becomes X. Where is the 2 coming from? You have 2 in the formula. So chromium now is 2X. You're going to add this to oxygen. So oxygen has 3, right, in the formula. Where is this minus 2 coming from? Your anions will always have a known charge. So oxygen will always be minus 2. It's not an X. We can look this up. We always know this, right? So that's why it's negative 2 in the parentheses. That's oxygen's charge, which is always known. The next thing you do is multiply your numbers. The 2x remains the same, but 3 times 2 is 6, and 2 had that negative charge, so it remains as negative 6. Now your goal is to solve for x. So algebraically, your next step is to move that 6 to the other side and get x by itself. And when you move it to the other side, 6 becomes positive. And then how do you get x by itself? You need to divide by 2. So 2x divided by 2 is just x. 6 divided by 2 is 3. So the proper name here is chromium 3 oxide. And yes, I know it looks like you could have just like undone the crisscross, like the 2 came from oxygen and the 3 came from chromium. Yes, that works here, and it does work some of the time, but it does not work all of the time. So let's try another one, Ni2O5. So first of all, you have to make sure nickel is type 2, and it is. It's in this green section right here. So we don't know the charge. Okay, so I set this up algebraically again. The red is my nickel. It's what I don't know. That's my X, and I have 2 of them. My oxygen, I have 5. Oxygen has a known charge because it's the anion. It is always minus 2, and together it equals 0 because we want this to be neutral. So the first thing I do is I multiply my numbers. So 2x plus 5 times 2 is 10, and you keep that negative, and it still equals 0. Now you are trying to solve for x, so you move the 10 to the other side, and it becomes positive. And then to solve for x, you divide by 2. 2x divided by 2 is x. 10 divided by 2 is 5. So the correct charge here is nickel 5 oxide. Now here's a good example of where that crisscross method, where you just undo the crisscross, is not going to work. So here we have Fe S. So Fe is type 2. If you look back at the table, it's right here. It's in that green section. And then S is my anion, and it always has a -2 charge. All right, so let's set this up now. So X is my unknown, right? So it's red. So I have one of them. I know there's no 1 written there. 1 is assumed. Okay, if there's no other number, then we're assuming it's 1. And then sulfur, again, there's no number written, so I use 1. And then -2 is its charge, because the charge of the anion is always known. So I multiply my numbers, and I have 1x. 1 times 2 is 2, and it keeps the negative, and it equals 0, because we want this to be neutral. Next, I move my 2 to the other side. So I have 1x equals 2. And then to solve for x, you just divide by 1. So 1x divided by 1 is 1. 2 divided by 1 is 2. So the proper name here is iron 2 sulfide. But if you had simply like undid the crisscross, you might have thought that it was iron 1. And that's not the case. It's iron 2 sulfide. Okay, let's try another one. So Au, it is a type 2 metal. And then we have Cl3. So Cl is chlorine, and we know that charge, right? Because it's the anion. So Au is my unknown. So I have one of them because there's no number in the formula, and that's my X. Chlorine, I have 3 of them, and chlorine's charge is always -1. So first thing you do is multiply your numbers. So 1x plus 3 times 1 is 3, and you keep that negative. Next, I'm going to move that 3 to the other side where it becomes positive. So 1x equals 3. To solve for x, you divide by 1. So 1x divided by 1 is x. 3 divided by 1 is 3. So the correct name here is gold 3 chloride. TiO. So let's set this up. So Ti is type 2. It's in the section labeled type 2. All right, and that's my X. That's the one I don't know. So I have 1. This is titanium. So I have 1 titanium, and its charge is what I don't know, so that's the X. Oxygen, I have 1, and oxygen's charge is always -2. So next, I multiply my numbers. So 1x plus 1 times 2 is 2, and you keep that negative. Next, I want to move this 2 to the other side where it becomes positive, and then I need to solve for x. So 1x divided by 1 is x, 2 divided by 1 is 2, so the proper name is titanium 2 oxide. So again, if you just undid the crisscross and assume that this was just 1 and 1, that would not be correct. This is titanium 2 oxide. Okay, last one. So we have SnO4. So yes, Sn is tin, that is type 2. So let's set this up. There's no number here, so that's 1. And tin is my unknown, so that's the X. Oxygen, I have 4. And the charge on oxygen is always -2. The anion is always known. Next, you multiply your numbers. So 1x plus 4 times 2 is 8, and you keep the negative. It equals 0 because we want this to be neutral. Next, you move that 8 to the other side, and it becomes positive. Now you have 1x equals 8, and you need to solve for x. So 1x divided by 1 is x. 8 divided by 1 is 8. So the proper name here is tin 8 oxide. So this is your type 2